All of you are able to see the slide, right?
Yes, ma'am.
Okay. So, warm greetings from CMR Institute of Technology. So, this is a GATE related training session, and this is a second part for the subject of geotechnical engineering. So, on this session, so it's me, Dr. Asha from CMR Institute of Technology, that will be who will be taking this session on this geotechnical engineering part 2. So in the part 1, already we have studied about the different the properties of the soil and also the different index properties and also the engineering properties. So in this session, we'll be trying to solve more of the numericals in this part. So before I start, let me extend my sincere acknowledgements to CMR Institute of Technology for giving me an opportunity to help the students in this forum, and AICTE Prerana scheme, so wherein it is exclusively meant for gay, and also gurus of mine who have enlightened me in this field of geotechnical engineering, and you, the audience, and also Wikipedia or any web-based resources I have used either in terms of questions or in terms of any pictures. Now, coming to the syllabus, so this is a geotechnical engineering. So it is having two parts. So this is the first part, as I have told in the last class also, like three-phase system, phase relationships, index properties, and all those parameters. And so this is all these parts we have actually had a glimpse in the first part. So it will be advisable all of you go through the first part. And the second part is basically application based, wherein we'll be dealing with the foundation engineering, earth pressure theories, and even footings, and so on. So today's session, we will be highlighting more about the problems that are there on the part 1. Okay, so I'm straight away going with the questions so that it will be rather than, already since you already have a concept on that, it will be good if you can straight away go with the problems or any questions that are coming. And please note there will be normally 1 mark questions as well as 2 mark questions. And there are these resources, I have questions, I have got it from web-based also. So aeolian soils. So aeolian soils are, it's a residual soil, or is it a wind deposit, or a gravity deposit, or a water deposit? So if you all remember, like in the last session I have told, residual soil is a soil which will be left out in the place after the um, any source of like erosion is left out. Wind deposit is something that wherein it is transported by wind, and any such deposit we call it as aeolian soils. Gravity deposit is a case wherein a particle settle in a place by virtue of its gravity or by virtue of its mass. And water deposit is a case wherein the particles are being transported by water. So in this case, the apt answer will be wind deposits. So because it is transported by wind, and it is for a 1 mark question. Now, a second question is like this. When the product of rock weathering is not transported as a sediment but remains in place, it is called as. So already I have told this answer in the first question itself. So when the product of rock weathering is not transported, it is settling in the same place. It cannot be an alluvial soil because it is being transported by means of water. Glacial soil is the one which is being transported by means of glaciers. A residual soil is the one which has been remaining in the place even after it is even after the source of erosion is over. It will be remaining there. And aeolian soil is a soil that will be transported by wind. So which will be the apt answer in this case? In this case, the apt answer will be a residual soil. Why it is residual soil? Because it is remaining in the same place even after the source of erosion is over. So when the product of rock weathering is not transported, so it is staying there. Okay, so that is called as a residual soil. So I hope this is clear for you. So this is also for a 1-marker question. Next. If the water content of a fully saturated mass is 100%. So, if the water content of a fully saturated soil mass is 100%, the void ratio of the sample will be. Please keep in mind for any such equations, whatever I have told in the part 1, the expression should be at your fingertips. So the moment you are given, it is water content, it is saturated. So the moment it is saturated, it is S and it is W, that is they are asking. So the water content is 100%. So they are telling like W is equal to 100% or it is equal to 1. And S is also equal to 1 because it's a fully saturated mass and they are asking for void ratio. Immediately we have to keep in mind the expression for the same and they are asking it in relation to specific gravity. So the expression that we have to keep in mind is ES is equal to WG. If ES is equal to WG, E is equal, S is equal to 1 because S is equal to 1, W is also equal to 1. So what will happen? E will become equal to G. So what are the options that we are having? Less than specific gravity of soil, equal to the specific gravity of soil, greater than the specific gravity of soil, independent of the specific gravity of soil. So the option will be B because we got the void ratio of the sample is equal to the specific gravity of the soil. So E is equal to G. So E is equal to G, your answer. So you can see the option is equal to the specific gravity of soil. I hope this is clear for you. Now, the next question. This is an objective question and there is no option also. So a certain soil is having the property G equal to 2.71, N is equal to 40. What is N? N is nothing but the porosity and W is equal to 20%. You are asked to find out the degree of saturation. So please note, see here also, what are you asked to find out? You are asked to find out degree of saturation. You are given G value. You are given N value. You are given W. Please note, you are asked to find out degree of saturation. What could be the expression that you may have to use? The expression that you may have to use is nothing but E into S is equal to W into G itself. But before you go with that, okay, before you go with that, you have to find out the value for E. Please note, if you look into the textbooks, you can find N in terms of E or E in terms of N. Don't get confused. Always follow only one expression because it is easy to remember one rather than remembering two. So here it is, you can see that N is equal to E by 1 plus E. So this you can remember. Don't even remember E in terms of N. So this is easy. So N is equal to 40%, which is nothing but zero point 0.4. Zero point 0.4 is equal to E by 1 plus E. So 0.4 plus 0.4 E is equal to E or 0.6 E is equal to 0.4. So you will be getting the value for E as 0.4 divided by 0.6, which is nothing but 0.67. Now, once you get the value for E, you already know what is the value for G. You already know what is the value for W. You can easily find out S by using the same expression that we have used last. What is that? E into S is equal to W into G. So this is the expression E into S is equal to W into G. So you know the value for E, you know the value for W, which is given 20%, G is also given. So you can easily find out the unknown S. So you get the value for S as 80.9 or 81%. So they have asked in the question also rounded off to the nearest percentage. So you can easily get it. So what will be the answer? The answer is going to be 81 percentage. Now, let us go to the next question. So, in its natural condition, the soil is having a mass of 1.980 kg and a volume of 0.001 meter cube. After being completely dried in an oven, the mass of the sample is 1.8 kg. So specific gravity G is 2.7 and unit weight of water is 10 kilonewton per meter cube. And you are asked to find out the degree of saturation. So how do we go with this question? You are given that the soil is having a mass of 1.980 kg and its volume is 0.001 meter cube. So what can you find out from this? So you are given the mass, you are given the volume, so you can easily find out the density, which is nothing but 1.980 divided by 0.001 meter cube. You also know that the mass of the sample when it is dried in the oven, which is 1.8 kg. So what will you get from that? Already you got wet density or gamma wet, or I can say rho I will get. Also I'll be getting rho D. So, so I am having now rho I have got, which is nothing but rho is nothing but 1.98 by 0.001 is 1980. Now, please note you are asked to find out the degree of saturation. Please, as I'm telling you repeatedly, you should be well versed with the equation because you should know which equation you have to use. Okay, because see in this question, you are asked to find out degree of saturation. So you know that the expression for dry density with the wet density, the relations that you have is rho d is equal to rho divided by 1 plus w, or it is also equal to g rho w by 1 plus e. And you know that if once you know e, you know that e into s is equal to w into g. So your objective is to find out the value for s. So this is how you are going to do that. So So rho is equal to 1.98 divided by 0.001, which is 1980 kg per meter cube. Rho d also I got, which is nothing but 1800. Now I am going to have rho d is equal to rho by 1 plus w. Substitute it as 1980. So 1800. So 1800 is equal to 1980 divided by 1 plus W. You get the value for W as 10 percentage because it is 1980 divided by 1800 minus of 1, which is nothing but 10 percentage. Okay. Now, once you get this value as 10 percentage, as I have told you, you are having one more expression, which is nothing but rho d is equal to g rho w divided by 1 plus e. Now, from this, you can get the value for e. You will be able to get the value for e. So, you got the value for e as, so how will you be getting 1000 into 2.7 divided by 1800 minus 1 will give you zero point 0.5 as a value for E. Now it is just the substitution in terms of E into S is equal to W into G or 0.5 into S is equal to zero point 0.1 into 2.7 and you get the value for S. So what will be the value for S that you'll be getting there? You'll be getting it as 2.7 into 0 0.1 divided by 0.5, and the answer will be 54 percentage or 0.54, and your option is C. So the answer you get is 0.54, which is again. Please note all these questions are only for 1 mark. So you have to understand the rapidity in which you should be doing it. Okay, because you don't even have 2 mark for these questions, so you should be very fast in doing. Next question. The ratio of saturated unit weight to dry unit weight of a soil is 1.25. If the specific gravity of solids is 2.65, the void ratio of the soil will be. So what are you given here? You are given rho sat and also rho d. So you are given that rho sat divided by rho d is 1.25, and you are asked to find out the void ratio. How do you get this? So you know that the expression for, see, please note, rho sat is equal to 1.25 times of rho w, and you also know the expression for rho sat, right, wherein S is equal to 1 into rho W. So from this, you will be able to find out the value for E. So the expression should be there in your fingertips, as I have told you. So you can say here, rho sat by rho D is equal to 1.25. Rho sat is equal to 1.25 times of rho D, and you also know that what is the value for rho d? You know that rho d is equal to g rho w divided by 1 plus e. So you know that rho d is equal to g rho w divided by 1 plus e, because when I am going to use this expression, my rho w should cancel. That is the reason why I am going to use it. So rho sat is equal to 1.25 times of rho d, okay, or otherwise it is going to be equal to 1.25 times of G into 10, because I am taking the unit weight of water as 10. It doesn't matter even if I take it as 10 or even rho W, because that's what I had done in the below step, divide by 1 plus E. Now see here, the next step, G plus E into rho W. What is this? This is this step. This is rho sat. We know that rho sat is equal to G plus ESR divided by 1 plus E into rho W. So G plus E divided by 1 plus E, because S is equal to 1, it is a saturated soil. So G plus E into rho W. So that is what you are taking. This is equal to 1.25 times of G rho W by 1 plus E. There is no need to put rho W value, because rho W value will get cancelled. Then what will be left out? G is equal to 2.65. 2.65 plus E divided by 1 plus E is equal to 1.25 into 2.65. Again, the denominator will get cancelled. So finally, you get the value for E as, how much will be the value? 1.25 into 2.65 divide into 2.65 minus 2.65. You will be getting it as 0.6625, or nothing but the option B, which is 0.663. I hope you can see the answer that I have put it in the bottom. So the answer is going to be B. Okay. So let us go to the next question. The porosity N and degree of saturation of a soil are 0.7 and 40% respectively. In a 100 meter cube of soil, the volume of air is. So please, you have to look into the question. This is a 2-marker question. And so the porosity, so you are given the value for N. What is N? N is equal to VV by V, right? N is equal to VV by V. which is nothing but you are given that what are you asked to find out? The volume of air, that is VA. You know that the porosity value is 0.7, which is nothing but VV by V. And what is the volume of soil given in the question? In the question, you are given that it is a 100 meter cube volume of soil. So what is the value for V? V is given as 100. So what will be VV? VV will be equal to N into 100, which is nothing but zero point 0.7 into 100, or it is equal to 70 meter cube. Now you are asked to find out what will be the value for air. How do you get the value for air? You know that S is equal to, you are given S, that is degree of saturation, which is nothing but VW divided by VV. Okay, and it is given as 40. But already you got the value for VV. What is VV? zero point 0.4 into 70, which is nothing but 28, right? So we know that the value for VW is how much then? So VW value will be equal to zero point 0.4 into VV. But you know that it is always VW plus VA is equal to VV. So if VW is zero point 0.4 times, definitely VA will be 0.6 times. So VA is equal to zero point 0.6 of 42, which is nothing, zero point 0.6 of 70, which is nothing but 42 meter cube. So the answer for this is 42 meter cube, and it's a 2-marker question, which has come in GATE 2016. A 588 centimeter cube volume of moist sand is weighing 1010 gram. Its dry density is 918 gram and specific gravity of solids is 2.67. Assuming density of water as 1 gram per cc, the void ratio will be. So here you are asked to find out the value for E. So what are you given? You are given the volume. You are given the moist sand. What does it mean? You will be getting the value for wet density or rho. What is the value for rho? Rho is nothing but mass by volume, which is nothing but 1010 divided by 588. You are also given the dry weight, which is 918 gram. So what will be the dry density? It will be 918 divided by 588. Now, you are also given specific gravity, and you have to just use the expression that we have already told in the previous sessions. You can look here. So you can say that rho is equal to 1010 by 588, which is 1.72. Rho d is equal to 1.56. Now you know that rho d is equal to rho by 1 plus w, and you can get the value for w as, what will be the value for w? W is equal to 10 percentage. You can just check it. So if it is going to be 10 percentage, so it will be 1.72 divided by 1.56 minus 1. It will be 0.1025. So you can round it out to 10 percentage. Now you are asked to find out what? It is nothing but E into S is equal to W into G. If you want, you can use that, or otherwise you can, but in that case, if you want to use that expression, S is not given. So you have to use in terms of rho D itself. So rho D is also given as G rho W divided by 1 plus C. So you please keep in mind, rho D is equal to, what are the expressions that we have done? Rho d is equal to rho divided by 1 plus w, or it is equal to, it is equal to g rho w divided by 1 plus. So by using these two expressions, you can get the value of, so you get the value for E as 0.71. So what is your answer? The answer is going to be 0.71. This is also again on the same similar topics. It is again for a 2-marker question. So the water content of a saturated soil and the specific gravity of soil solids were found to be 30% and 22.7 respectively. Assuming that the unit weight of water has to be 10 and the saturated unit weight is the saturated unit weight and also the void ratio of the sample are. So you are asked to find out the saturated unit weight as well as the void ratio. Now, please, whenever you do such questions, especially in any of these competitive examinations, more than trying to find the solution, you should always be smart enough to eliminate your answers also. So please look into the options. So any such options, whenever any such question, generally when you get, you should be very clear in how to eliminate, because then only you will be able to save the marks. So you can see here 19.4 is there in two places, 18.5 is there in two places. Here also you can see 0.5 is there in two places. So you should know how to eliminate it. Okay. So if you get one answer, you should be able to eliminate at least two options. Okay. Now let us see how to do this. How do we do this question? You are given the W value. So W is known. G is known. So then what can you find out? So you are also given that the water content of the saturated sample. So that means S is also given, right? So W is there. So if you look into the fundamental, you are asked to find out void ratio. So you have to use the fundamental equation. E into S is equal to WG. So you can easily find out the value for void ratio. So what will be the E into S is equal to W into G, and your answer is going to be E into 1 is equal to 0.3 into 2.7 is equal to 0.81. Now, please be careful over here. See, you have got the option wherein 0.81 is there only for one answer. So your answer you're getting is going to eliminate all your options. But still, you can just check whether you get the value. So you should be always able to answer this question easily, because you got easily the answer of 0.81. Now, how do you get saturated unit weight? You know that what is the expression that you use? So rho sat is equal to rho sat is equal to G plus E into S into rho W divided by 1 plus E. Rho W already you know. S is equal to 1 because it's a saturated unit weight. So this is what I have written here. So G plus E into rho W by 1 plus E, just substitute. So G is 2.7 and E is 0.81 and also 1 plus 1.81 into 10, and you will be getting this answer as, or what will be the answer you'll be getting? 2.7 plus 0.81 into 10 divided by 1.81. You'll be getting it as 19.4. So this verifies your answer. So your option is 19.4 and 0.81. Okay. So always whenever you do such examination, all these topics, you should be always able to eliminate your answers. Yeah. Next question. In a shrinkage limit test, the volume and mass of a dry soil patch are found to be 50 centimeter cube and 88 gram respectively. The specific gravity of the soil solids is 2.71 and the density of water is 1 gram per cc. What is a shrinkage limit? So this is very, whenever I gave a recap in the last class, I have not highlighted more expressions on shrinkage limit test. So, but be very clear with the phase diagram and also on the consistency limits that I have told. So, whenever you have this consistency limits, so please remember, see, you will be having, this is the way in which the volume versus water content relation will be going. So, this is going to be your shrinkage limit. This is going to be your plastic limit, and this is going to be your liquid limit. Now, what is the speciality of this part? So, shrinkage limit is nothing but the water content at which I can say that it is the lowest water content at which there is no change in the volume. So, here if you look into it, the volume of the soil, if it is V, okay, so here as well as here, it is greater than V. The volume is greater than V. You can see here, this is a y-axis is volume and this is water content. So volume keeps on increasing. So shrinkage limit, up to shrinkage limit, the volume will remain the same. So don't, whenever you see a shrinkage limit as such in the question, you don't have to get scared. Oh my God, I don't remember the expressions or not. See, this is just a problem based on phase diagram. You are given the mass is given. What mass is given? You are given the dry mass and also you are given the volume, and you are asked to find out what will be the shrinkage limit. So it is nothing but water content they are asking. So for from a saturated soil, it has become like now dried, and they are asking you to find out what is the water content for that. So how do you do this? First, you have to find out the dry density. See, you are given dry soil pad mass and also the volume. So what will be rho D? Rho D will be equal to 88 by 50, which is nothing but 1.76 gram per cc. Now, the moment you get the value for rho D, how do you go for the next part? You know that it is going to be a saturated condition. Please keep in mind, shrinkage limit means it's a saturated condition. So if it is saturated condition, what expression you can use? Rho dry is equal to G rho W by 1 plus E, and E is nothing but WG by S. But S is equal to 1. Therefore, rho D is equal to, you can see here, it is equal to G rho W divided by 1 plus Wg by S. Since S is equal to 1 at shrinkage limit, it is equal to 1 plus Wg. Now, what are you asked to find out? You are just asked to find out the value for W. You are given rho D, you are given G, you know rho W, and you have to just find out the value for W. And you will be getting this expression. So the answer is 19.91. Okay, so this is the answer how you, and also please note, if you are very keen, because in fact whenever you have studied the shrinkage limit also, you would have also studied an expression for shrinkage limit. If you know the volume or if you know the density of the pat, okay, so that expression is W is equal to rho W by rho D minus 1 by G. If you remember this equation, straight away also you can substitute. But if you find it is very difficult for you to mark up so many formulas, it is always good you can even go by this method. The next question is the laboratory test. I hope all of you are hearing me. Are you able to hear me?
Yes, ma'am.
Okay. So the next question. The laboratory test on a soil sample yield the following results. Natural water content is equal to 18%. Liquid limit is equal to 60%. Plastic limit is equal to 25%. Percentage of clay size fraction is equal to 25%. The liquidity index and activity as per the expression proposed by Skempton are. So what is liquidity index? Liquidity index IL is equal to WN minus WP divided by IP into 100. See, WN minus WP divided by IP into 100. So what is WN? WN is already given as, what is the value for WN? It is 18. What is the value for plastic limit given in the question? It is 25. IP is how much? Liquid limit minus plastic limit, which is nothing but 60 minus 25. Substitute all these things. How much will be getting? It will be 18 minus 25 divided by 60 minus 25. So your answer is minus 0.2. Here, as usual, I told your answer is clear. Which is your answer? You have A, B, C, D. Minus 0.2 has got only in option A. So you should be moving around A. So you are expecting an answer of 1.4 for the next part, right? For activity also, you're expecting the same. How will you get activity? How do you cross check that? Activity is equal to like plasticity index IP divided by percentage of clay fraction. What is IP? IP is nothing but 60 minus 25, which is nothing but 35, divided by F is nothing but 25. Substitute it, got it as 1.4. So your option is very clear. So your option is minus 0.2 and 1.4. So the answer will be option E. So please note, this is also a 2-marker question for the GATE examination. And I'll tell you one more thing. So whenever you focus on this GATE examinations, I'll tell you for the geotech subject, uh, the probability of you knowing the answer is very high for most of the questions. So it is only that you have to just practice a few things. And whatever the materials that I'm telling, so you can use this as a basis and you can keep on exploring similar kinds of things. So it is very easy and at the same time, and also I'm telling you, among the different subjects, generally, but sometimes slightly based on the set, it may vary. The geotech subject is the subject which occupies the major share in the GATE examinations. Okay, if you look into the subject of structures and all also, when compared to that, geotech is the one that occupies the highest. So the option is minus 0.2 and 1.4. Next question. The relationship between specific gravity of sand and hydraulic gradient to initiate a quicksand condition in a sand layer having a porosity of 30%. Please keep in mind what is the expression that you have to use whenever you have to determine the quicksand condition. The critical hydraulic gradient is given by G minus 1 by 1 plus E. Please note it's just a 1-marker question. So the critical hydraulic gradient, it is given by G minus 1 by 1 plus E. Now you are given that the porosity N is equal to 30%. So N is equal to E by 1 plus E. So find the value for E, which is equal to 0.43. How did you get it? N is equal to E by 1 plus E. N is equal to 0.3 divided by E by 1 plus E. So you will be getting this as your 0.3 by 0.7. So your answer will be 0.43. Now, once you get the value for 0.43, so what will happen here? You are asked every expression is in terms of G. So G is equal to 1 plus E will become 1.43. So 1.43 I plus 1. Which expression is there? Option C. So you can see here, please note the answer is 1.43 I plus 1, but your option is given 1.4 I plus 1. Don't worry because that is the closest answer. If you round it up, 1.43 will become 1.4. So the option is, it's not A, it's option C. Okay, so it is going to be 1.4 I plus 1, which is the option number C. Next question. A fine grained soil has 60% by weight of silt content. So which is nothing but, what does it mean? A fine grained soil has 60% by weight of silt content. So this is nothing but percentage of fines. The soil behaves as semi-solid when the water content is between 15 to 28 percentage. So what do you mean by semi-solid? So if you look into that consistency, you know that it is going to be from solid state to semi-solid state and from there to plastic state and then to liquid state. So it is going to behave as a semi-solid state when the water content is between 15 to 28. And also it is going to be a fluid like when the water content is more than 40%. So anything that is more than the liquid limit is something that we call it as fluid. And if there is anything that is between the plastic limit, so in the plastic limit only, the soil will be behaving like a semi-solid condition. Now you are asked to find out the activity. How do you find out? Activity is equal to IP by F. Please see here, for plastic limit, you are not given one single value. Instead, you are given a range. So you can take the average 15 plus 28 by 2, which is nothing but 21.5. So liquid limit is nothing but 40. So 40 minus 21.5 divided by 60. What is 60? F is nothing but the percentage of clay fraction, and therefore activity is equal to 0.3. So what will be your option? You are having only one option, that is option C. Again, please note it's only a one marker question. So you should be very fast in doing these questions. Next question. I think I repeated once again, so I'll just take down to the next question. Yeah. So the coefficient of permeability of a soil is 5 into 10 to the power of minus 5 centimeter per second for a certain pore fluid. So you are given that the value for K is equal to 5 into 10 to the power of minus 5 centimeter per second. If the viscosity of the pore fluid is reduced to half, the coefficient of permeability will be. So you are given that the condition is going to be the viscosity is reduced to half. How is permeability related to viscosity? Please keep in mind, you have to remember Hagen-Poiseuille's equation. So Hagen-Poiseuille's equation, if you remember, you can see that K is given by C. C is nothing but a parameter which correlates with its shape into E cube by 1 plus E into gamma W by mu into D square, where D is nothing but the effective size. Now, you are asked that What is the permeability if the viscosity is reduced to half? So K is inversely proportional to viscosity mu. So if K is inversely proportional, how will you get it? So if my viscosity is getting reduced by half, so K should be getting doubled, right? So if this is a case, then K should be getting doubled. Why? Because K is inversely proportional to viscosity. K is inversely proportional to 1 by, or K is proportional to 1 by mu, or we can say that K is equal to double the times of that. Now please note, so what will be the answer in this case? In this case, the answer will be, if this has to get doubled, so answer should be 10. 10 into 10 to the power of minus 5. Now, please note, this expression is highly important because many a times, not only in terms of viscosity, the same expression we can be asked, we can expect the questions wherein it is correlated to E. So K, how when E is increasing or E is decreasing, how is K changing? Even you can get questions wherein it is correlated to D also. If D is changing, how exactly the value of K is going to change? So please note this is a very, very important expression. If you know this, you can go do any type of problems that comes in this regard. Yes, the next question. The piezometric head at point C, there is a point C, this is a point C. In the experimental setup shown in the figure, when the flow is taking place under a constant head through the soils A and B is. So you have to be very, very careful whenever you are going to deal this, because see, you are given that the piezometric head for the point C. Please note, you are not asked to find out with respect to free surface or anything. With respect to point C, which is over here. What will be the head? See, and also you are assuming that the flow is taking place. So water will be flowing from upper head to lower head. So here water is going to flow. So probably if you remember how you have done the permeability problem itself, you will be making the water to flow from the permeameter, that is from the tank, and you will be noting down the head. What will be the head? So this head that is available here will only cause the flow of water up, right? So what is the head that will be available here? It will be 40 plus 40 plus 40. It is nothing but 120. Please note it's not 140 or anything. It's not 40 or anything. Why? 40 will come only if the pressure difference is between these two. You are asked with respect to top and bottom. Because you are not asked over here. If they are asked with respect to like how we do for permeability, we'll do it for the top. But in this case, we are doing it for the point C, which is nothing but over here. So what will be the head that is required for the water to flow? It will be 40 into 3, which is 120. 120 centimeter. Now, next one. According to Darcy's law, for flow through a porous medium, velocity is proportional to. What will be the answer for this? According to Darcy's law, so velocity, so you know that the velocity in the case of a velocity of flow, in the case of Darcy's law, V is equal to K into I. So what is I? I is nothing but hydraulic gradient. So it is independent of effective stress, cohesion or stability number, or I can say that it is dependent only on the hydraulic gradient. The next one. For an anisotropic soil, permeabilities in the x and y directions are Kx and ky respectively in a two-dimensional flow. And the effective permeability for the soil will be given by. So how do we find out the effective permeability? So the effective permeability in this case is given by square root of kx into ky. So what are the options that are given here? Kx plus ky, it cannot be the answer because that cannot happen. Kx squared plus ky squared the whole raised to half, yes, that also is not possible. Kx by 5 ky is also not possible because we have not at all come across such things, but instead we have told like if it is for an anisotropic soil, it can be kx into ky the whole raised to half, or it is nothing but square root of kx into ky, right? So this is what exactly it is. A soil mass. So the next question, the soil mass is having a coefficient of horizontal and vertical permeability as 9 into 10 to the power of minus 7 centimeter per second and 4 into 10 to the power of minus 7 centimeter per second. The transform coefficient of permeability for an equivalent isotropic soil mass. How do we do this? You know what is kx? Horizontal is kx, vertical is ky. You know what is horizontal, what is vertical. You are also asked to find out the transform coefficient of permeability. How do we get it? It is given by square root of kx into ky, which is nothing but square root of 9 into 4 into 10 to the power of minus 14, which is nothing but 36 into 10 to the power of minus 14, or it is 36 square root is nothing but 6. So 6 into 10 to the power of minus 7. So please note, I have not written down the unit. So what will be the unit? It will be centimeters per second. So the answer is D. Okay. This is also just a one marker question. Two tubes shown in the figure may be considered to be permeameters. Dimensions of the sample in the figure are alike. Okay. And the elevations of head water and tail water are the same. Okay. The elevations of head water and tail water are the same for both the figure A and B. So what they have told us, you'd have to just keep in mind that the tailwater level is also the same. Though the size is slightly different on appearance, it is the same. And they are asking you to find out what will be the head loss through these samples. So what are you given here? There are two tubes. There are two tubes, and these tubes, okay, they are considered to be the permeameters, and the dimensions are alike. So that means you have to, don't worry about the cross section. So head is nothing but dependent upon the height. And also the elevations of head water and tail water are the same. So what does it mean? What are you going to what you have to find out? And also they are asking you to find out through the samples. So what is the sample here? So this is the top of the sample and this is the bottom of the sample. In this case, this is the top of the sample and this is the bottom of the sample. What is the head for the? So they are asking you for first figure and second figure. For first figure, what is the head that is available for the top? How do you know what is the pressure there? You insert a piezometer, you will see what is the height of the water. So that is the pressure at that. So what is the pressure here? It is here. It is A. Where is the water bottom part? Bottom part is here. But when you connected the piezometer, water is coming till here. It is nothing but B. So what is the answer for first one? It is going to be AB. Why we cannot take AD? Why we cannot see? It cannot be BD because B is nothing but not coming on the top. Then AD will not come. Why AD will not come? Because there is no soil itself. It is only the water surface. Whereas D is nothing but this is also bottom of the surface, but water pressure is not at that point. It is at B. Okay. So the pressure here is going to be AB. What will be the case for the second case? In this case, it is A. And please note here there is a problem in the figure. Actually, it is still here. Okay. So this is still here because they have already told the tailwater level are also in the same level, both the figures. So that is B. So what will be the water level here? The water level in this case also will be equal to B because this is the level B and this is going to be the where the piezometer is also coming up. So what is the pressure for the point for the figure 2? That is also going to be AB. So AB, you are having only one answer, that is this. So as I told you, if you are trying to do this elimination part, we can even eliminate the other options by knowing the first answer itself. So what will be the answer here? Equal to AB. Okay. Next question. A river 5-meter deep consists of a sand bed with a saturated unit weight of 20 kilonewton per meter cube. Gamma W is equal to 9.81 kilonewton per meter cube. The effective vertical stress at 5 meter from the top of the sand bed is. So the moment you see this question itself, you have to make a sketch so as to make it very clear for you. So you are having a river bed and the river is 5-meter deep. So this is going to be 5-meter. This is having, what will be there on this river? This will be river water only, right? Now, you are asked to find out what will be the effective vertical stress at. So you are not asked to find out of anything else. You are asked to find out the effective vertical stress at 5-meter from the top of the sand bed. So from here we are having sand bed and for a depth of 5-meter. Only for the sand bed is what they are asking. So how do you get this? So this is going to be, because in this case, your sand is going to be submerged condition, right? Your sand is going to be in a submerged condition. So what is going to happen? Sigma dash is equal to rho sat minus rho W into H. So what is the submerged condition? What is the value for rho sat? Rho sat is nothing but, what will be the value for rho will be nothing but gamma into H, gamma sat into H. So you are given gamma sat is 20 and also you know gamma W is 9.81. So 20 minus 9.81 the whole into 5, which is nothing but 50.95 kPa. Okay. Now you don't have to, because in this case they are asked exclusively for the riverbed. Please note, you don't have to find out for the water asset, because for water it is nothing but 10 into 550, and you don't have an option which is more than 50, only 50, because if to this you cannot add 50, because they are only having an option starting from this itself. So since they are asking effective vertical stress, it is what exactly? Sigma minus U. Okay, rho sat minus rho W. So that is what you are having the answer as 51 kilonewton per meter square. So hope all of you are hearing me. Are you all there?
Yes, ma'am.
Okay. Yes. I hope all of you are able to hear me properly, right? Are you able to hear me properly?
Yes, ma'am.
Yes, ma'am.
Okay. Yes. Next question. The coefficient of permeability of a soil in horizontal and vertical directions are 3.46 and 1.5 meter per day. So you are given the values for kx and also for ky. Base length of a concrete dam resting in the soil is 100 meter. So the already you are given that the field case, the value for the base length of the concrete dam is 100 meter. When the flow net is developed for this soil, but 1 is to 25 scale factor in the vertical direction, the reduced base length of the dam will be. How do we do this? You know what is the value for kx. You know what is the value for ky. You know what is the actual base length of the concrete dam. Now, they are asking you to find out the reduced base length of the dam with respect to the flow net. So, please keep in mind, first you have to scale down your field 1 to the flow net size. So, how do you scale it? It is given as a scale factor 1 is to 25. Okay, so before we start with this, please keep in mind this I have shown in the last class. The whenever you don't have a isotropic condition, whenever there is an anisotropic condition, you have to transform the axis in such a way that all the it can be expressed in the same as an isotropic condition. So how do you do the transformation? X of t is equal to x into square root of kz by kx. So if I want to transform in the x direction, it should be x should be multiplied in terms of square root of the other directions permeability to the same directions permeability. So if I have to multiply scale factor for this x, okay, what should I do? I should multiply with kz and then divide by kx. Similarly, x of z is equal to c function, c depth into square root of kx by kz. Okay. So please note, whatever we are doing flow net, everything is a two-dimensional representation. So how do we do this? First, we have to scale the base length, that is 100 meter, should be scaled down, that is 100 divided by 25 is the scale factor. So what will be the base length of the dam? The base length of the dam will be just 4 meters. So once you get 4 meters, that you have to transform to the with respect to the isotropic condition. How do you do this? Because in the vertical and horizontal directions, the permeabilities are different. So yt is equal to y into square root of kx by ky. So what is y? Y is nothing but 4, which is nothing but the base length. Okay. So x into square root of, okay, what is it that you require into 1.5, okay. So it is vertical directions, okay, divided by horizontal direction. So which is actually it is yeah, ky is vertical. Here there is a small mistake here. So here we are not going to, because base length is which dimension? It is a x dimension, right? So this is xt. Yeah. Okay. Because what is a base length is which dimension? It is a x direction, right? It's a horizontal dimension. So x, if I have to scale, I have to multiply with square root of ky by kx, which is nothing but vertical value for k is 1.5 divided by for horizontal is 3.46. So we will get it as 2.63 meters. Okay. Please note this is a 2-marker question. Okay. Now, Tarsagi's one-dimensional consolidation assumes that what will be the value that will be assuming? E versus P relationship is linear. No way. We don't have E versus P relationship as linear, because if you remember the graph itself, if you try to plot, so if this is E, this is P, you will get this graph like this, right? So it is never a linear relationship. So E versus log 10P is a linear relationship that is linear. Yes, that is true, because once you do this, you get this as like this. So it is a linear relationship. So this is E versus log of P. P versus log to the base 10 E relationship is linear. No way. Once you take natural logarithm, only that relationship will become linear. E versus log 10 to the base of P by P naught. What is P by P naught? That is the final pressure divided by the original pressure. It is linear. That is also false. So what option is your correct one? It is a B option, which is E versus log to the base 10P relationship is linear. Okay. So please note, how did we start with? We completed the phase diagrams. We did all types of problems on phase diagrams. Then we came to Atterberg's limits. We did some problems on Atterberg's limit. Please note, these are not the end of the problems. This is just a way in which you can start into it. So we did problems on Atterberg's limits, and then we came to this one. What is that? Permeability, and now we are into consolidation. The coefficient of consolidation is used for. So what is it used for? It is used to determine the duration of primary consolidation, estimating the amount of settlement for a given load increment, then determine the depth to which the soil is stressed when the loads are applied on the surface of a soil deposit, and determine the pre-consolidation pressure for soil deposits known to be over-consolidated. What can be the reason? You generally know that whenever we take settlement versus time relationship, time if you take here and also settlement here, it will be generally having a graph like this. The first part, we call this as immediate settlement. So sometimes we can even get the graph like this. So probably whenever we have studied the um, uh, logarithm timing fitting method as well as the square root time fitting method, you can see all those differences. So what happens is initial part will be immediate settlement. So that expression is given by qb squared by 1 minus mu qb into 1 minus mu square into. So that expression you are already having. So that will be coming upon later. And then in the consolidation part, we are looking only onto this part. So establishing the duration of primary. So this is your immediate, this is your primary, this is your secondary. So in this case, the coefficient of consolidation is used to determine the duration of primary consolidation. Estimating the amount of settlement is not a part, because estimation of settlement is going to be a part of the consolidation test, because whenever we give a time duration within that, the settlement is going to be a part of it, but not the whole thing. Determine the depth to which the soil is stressed. Yes, we cannot determine directly. Then determine the pre-consolidation pressure for soils deposits known to be over-consolidated. So it's not like that. So we have to just find out what exactly will be the primary consolidation by means of using this consolidation experiment. Immediate settlement is also a part of the consolidation. So what will be the answer for this? It will be A, which is nothing but estimation of the duration of primary consolidation. The nature of contact pressure distribution under a rigid footing resting on a sandy soil subjected to uniformly distributed load is as shown. You have to select the correct option. What will be the correct option here? Please note, I'm having one more slide actually on this part. So, see, whenever you have to keep in mind, there are two types of footing, that is a flexible footing as well as a rigid footing. Okay, so if a footing is going to be flexible, what happens? The settlements will be elastic, whereas the footing pressure will be more or less uniform. Whereas if it is a rigid footing, what happens? The settlements will be uniform, whereas the contact pressure will vary. It is going to vary based upon the type of the soil. Okay. So before I go on to this slide, I will just explain you one part. So please, this is a very, very important part. So on a saturated clay, so if it is a saturated clay, and I am going to have a flexible footing, you can see here the footing settlements. The footing settlements is going to be more for the center and it decreases towards the edge. Please note this is for clay, whereas the pressure is more or less uniform. Whereas for a rigid footing, what is going to happen? The settlement is going to be uniform. And here it is going to be having a lesser value for contact pressure in the center, and it is going to increase towards the edges. The reason why it is going to increase towards the edges is because there is more and more of cohesion that is happening. So that is why it increases, but it cannot increase infinitively, because the moment it crosses one part, what happens? Either heave will happen. There will be plastic flow that happens beyond the footing. So that is why it reaches a finite value as shown. Now, whereas in a similar way, if I take for a sand, you can see for a flexible footing, you can see that the settlement is going to be, so here what is going to happen? The sand will be always having less settlements in the center. Why the sand will be having less settlements in the center? The reason is because the sand as such is not going to have any cohesion. So, but what happens is like at least more and more of particles will be surrounding the particle in the case of a sand, okay, in the center part. So that is why you can see that the deflections or the deformations will be slightly, it will be less, and here the pressure will be more or less the same. Whereas if you look into the case of the sand footing on a sand rigid footing on a sand deposit, you can see that the contact pressure decreases towards the edges. Why it decreases? Because at the edges it doesn't have what you call no, that dense packing is not there, because here the particles are free to heave to the sides as well. So that is the reason why the distribution for sand will be as per the this figure. Now let us go back to the first question that we were discussing. So, so what will be the answer in this case? In this case, the answer will be B, because this is going to be typical for a tougher flexible. Okay, so that's why we are not going to consider here. And this is also for a clay. So what is the answer for this case? This is a case for this answer is going to be B. The slope of E versus log P curve for a soil mass will be giving you what all things will, what will you get? We'll be getting coefficient of permeability? No way, we cannot get. Coefficient of consolidation? No, because coefficient of consolidation, it is obtained with respect to dissipation of pore pressure. Compression index? Yes. Coefficient of volume compressibility is again a function of delta E as well as delta sigma. So what is the answer for here? So the answer for this one is going to be option C. How do we get this? So if I am going to have E versus sigma, you can say that it comes down. Now this part is called as CC. This part slope is called as CC. Now if I unload the specimen, you can see that it will come down till here. And if I reload it, it will come down this. Okay, so this phenomenon, so the slope of this part, this is called as recompression index. Okay. So the slope of E versus log P curve for a soil mass is given by compression index. Sand drains are used to. It's also again a one marker question. So what is it used for? It's basically used to accelerate the consolidation. How is it function? Suppose this is going to be an embankment. You found out that this is having more amount of water. So what are we going to do? We have some drains being constructed. It is made up of sand. So the sand will have a lesser permeability when compared to that of the surrounding clay. So what happens is from the all this, so you will be having some mechanism to drain out water from here, and we will have all this water going inside from the sides. And thereby there will be lots of water can be collected, and this can accelerate the consolidation. So the answer is B. Next one. The stress-strain behavior of soil is given by. This is a very, very important concept. So there are two curves that are given here, curve 1 and curve 2. So you can see the options. Curve 1 is for loose sand and it is for a normally consolidated clay. What is curve 2? Is again a loose sand and over consolidated clay. So they are trying to club two conditions. What are the two conditions? One is the type of consolidation and second one is the type of the what is that? The type of the material. So if it is a loose sand, what type of behavior will be shown? Please note this behavior, we call this as strain hardening behavior. And this is called as a strain softening. So the top one is called a strain softening. Please note, dense sand will always have a strain softening behavior, and this condition that they reach, we call this condition as critical state. Okay. So what is the condition that will be coming here? So curve 1 is going to be loose sand and a normally consolidated clay. So here we can see that the curve, the first one, okay, so it is a sand. So whenever it is a dense sand, it will always have a what type of condition? The dense sand will always show a strain softening behavior. I'll just escape this so that yeah. So dense sand will always have what type of behavior? Strain softening behavior. So this statement will it not? It will be. It is correct. Curve one is not sorry. Curve one is corresponding to a dense sand and a normal over consolidated clay. Okay. So for dense sand and over consolidated clay, they will give curve one option, and curve two corresponds to a loose sand and a normally consolidated. So which option is giving that? So dense sand and over consolidated is here, loose and normally consolidated here. Your option is C. Okay. The next one. The time for a clay layer to achieve 90% of the consolidation is 15 years. The time required to achieve 90% consolidation if the layer were twice as thick and 3 times more permeable and 4 times more compressible, then it will be. So you are asked to find out what is the time taken for the clay. Already you know what is the time taken to achieve 90% consolidation for a given clay thickness. Next is going to be when the thickness is doubled. Permeability is 3 times, okay, and compressibility is 4 times. So how is it going to happen? Tv is equal to Tv into h squared by T, or T, because we always deal with T. So T is nothing but Tv into h squared by Cv. So this is the value. Now for second case, whatever they are given, Cv is given by, always you please note, Cv is equal to K divided by Cv is equal to K divided by Mv into gamma W. Or we can say that C is proportional to K divided by Mv. So what is going to happen if this is going to be proportional to K divided by Mv? So permeability is how much it is becoming? 3 times. And compressibility is becoming 4 times. So it is going to be 3 by 4. So Cv dash is equal to Tv into h dash by T dash, or 3 by 4 Cv is equal to Tv into, what will be the value for h? It is going to be 2h now. So it is going to be 2 square, which is nothing but 4h. H squared. So Cv 3 by 4 Cv is equal to Tv into 4h squared divided by T, or T is equal to 16 Tv into h squared by 3T, and the answer that you will get on simplification will be so please note. So how much is this one? So this, if you look into it, this term, the remaining term, what is the remaining term? Tv into h squared by T, you already have the answer for that. What is that? 15 years. So 15 into 16 by 3, it is 80 years. So the answer is going to be 80 years. So the time taken, how did we do this question? So what did we do? See, please note, CV is equal to, CV is proportional to K and MV. This is also very, very important relationship that generally will be asked. And also please note, this is a 2-marker question also. So CV is equal to TV into H squared by T, and CV is proportional to K by MV. So now what is going to happen? CV dash is equal to TV into H dash squared by T dash. So 3 by 4 CV is equal to TV into 4H squared by T. And also you know that CV into, so all these things you can substitute. So wherein, so CV already you are having, I think here, it's not T. 3 by 4 CV is equal to TV into 4H squared by T. So, but we know that TV into H squared by this one is equal to already 15. So, we have to just substitute for that. So, that's why you will get it as 80 years. Now, 2 series of compaction tests were performed in the laboratory on an inorganic clayey soil. So, now we have completed compaction. Now we have come to consolidation we have completed. Now we have come to compaction. So 2 series of compaction tests were performed in a laboratory on an inorganic clayey soil, employing 2 different levels of compaction energy per unit volume. With reference to that, answer the following. So, the optimum moisture content is expected to be more for the test with higher energy. Then second one is the maximum dry density is expected to be more for the test with higher energy. So what will be the answer for these two? So at the moment before you start answering, immediately you should be having in your mind the compaction curve as well as its relation with the energy. Okay. Now you can see that this is a compaction curve. If you increase the compaction curve, it will come like this, wherein dry density will increase and moisture content will decrease. So in this case, which one will be correct? So the optimum moisture content is expected to be more for the test with higher energy. Optimum moisture content, is it going to increase or decrease? So optimum moisture content is here, it became here. So the optimum moisture content is going to be decreased, right? It is going to be decreased. And what about the dry density is going to increase? So that is the second option. The maximum dry density is expected to be more for the test with higher energy. So what will be the correct answer? Only one is true, one is false, right? So that we cannot take. Then second one is only 2 is true. Yes, that is correct. Okay. Then what is the next one? Both 1 and 2 are true. No, it's only option 2 which is correct. Neither 1 nor 2 is true. That is also wrong. So which will be our option? Our option will be B, which is nothing but only 2 is true. Now this is a very simple question. So in a compaction test, G, W, S and E represent the specific gravity, water content, degree of saturation and void ratio of the soil sample respectively. And if gamma W represents the unit weight of water and gamma H represents gamma D represents the dry unit weight of the soil, the equation for the zero air void line will be, what will be the expression for zero air void line? So there are 2 expressions for zero air void line. In this case, please note that for zero air void line, NA is equal to 0, or otherwise S is equal to 1. But we can have so many lines parallel to a zero air void line, or with respect to like a saturation line, in such a way that these two lines, they will be what you call, no, one will be the reading, that the graph that corresponds to S is equal to 0.9 and N is equal to 0.1 will be different. What is the expression that we generally have? Just a minute. What is the expression that we generally have? For rho d is equal to g rho w by 1 plus e. Okay. So in this case, if at all you want to find out for the zero air void line, E should be replaced with G rho W divided by 1 plus WG by S, but S is equal to 1, therefore this is equal to G rho W by 1 plus uh, WG. What will be the answer in this case? It will be option B. Now, deposit with a flocculated structure is formed when? So, the clay particles, when they settle on seabed, clay particles settle on freshwater lake bed, sand particles settle on river bed, sand particles settle on seabed. So, please note that when the moment you are seeing this, you have to keep in mind always the C will be always having a charge, right? So, please see, since they are having a salt content, they will be having a charge, and the moment you put like our soil into the such a water, what happens is like it will automatically get polarized. So which will be, and the moment it gets polarized, what happens? The bonds will be developed in such a way that they will be from the edge to corner and so on. So the option, which option will be the right option? So in this case, a deposit with a flocculated structure is formed in the case of a seabed. Why it cannot be freshwater or river bed and all? Because there will be no charge for the water, and accordingly, what happens? The clay particles will also not get charged. That's the reason. Then, sand particles can be considered that also as an option. Sand cannot be considered because sand particles do not have a charge. Okay. Because of that only, the option can be only A. Compaction for by vibratory roller is best suited for the compaction of moist sand. Can we do vibratory roller? It will be very difficult because the clay water will try to cover up the sand, and it will be preventing it from getting into a stronger binding. So well graded dry sand, yes, it is a good choice. Okay. Clay with medium compressibility, no way, because clays generally we use only sheep wood rollers. And sills of high compressibility, even sills also we don't use it because of the uh, uh, like uh, uh, since they also have a clayey finer nature, they cannot be done. So generally for the vibratory method, we resort it only by means of dry sand. Now what about clay? Clay particles, which is the best type of compaction device? It is going to be uh, sheep foot roller, because the kneading as well as the rolling action imparted by the sheep foot roller helps them to achieve a higher density. Next question. So in a compaction test, as the compaction effort is increased, the optimum moisture content, what will happen to the optimum moisture content? So the if the compaction, as I told you, once the compaction effort is going to be increased, the optimum moisture content will be trying to decrease, right? It is going to decrease. The zero air void curve is a nonlinear curve owing to. What is the reason why the zero air void curve is a nonlinear part? The standard Proctor test data, the standard Proctor test data of the dry density and corresponding water content plotting as a nonlinear curve, or otherwise the dry density at 100% saturation being a nonlinear function of the void ratio, or the water content altering during compaction, or the soil being compacted with an odd number of flows. So, what can be the reason? The reason is because it is going to be the dry density at 100% saturation is always going to have a nonlinear function with respect to the void ratio. So the ratio will be the in a form of a nonlinear function. So that is the reason why we have a curve. The unit weight of a soil at zero air void depends upon. How do we get it? How do we get this equation? The unit weight of soil at zero air void content. So you have to rho d is equal to so rho d is equal to g rho w by 1 plus wg. What is g? G is a specific gravity. Rho w is going to be the unit weight of water, and water content is going to be there. And also, so g is already we have told. So what is the expression? It will be all of the above. So this is another question. So in a standard Proctor test, 1.8 kgs of moist soil was filling the mold after compaction. A soil sample weighing 23 grams was taken from the mold and oven dried for 24 hours at a temperature of 110 degrees Celsius. Weight of the dry sample was found to be 20 grams. Specific gravity of soil solids is 2.7. So, how do we do this question? First, we are given that it is 1.8 kg of moist soil. So, what does it mean? 1.8 kg of moist soil, and also the volume is 944. Now, in this case, first and foremost thing, keep in mind what are you asked to find out the theoretical maximum value of dry unit weight of the soil at that water content. So, they are asking with respect to the zero air void line. Any density corresponding to zero air void line, we call it as a theoretical density. So, what is water content? Is equal to mw by ms into 100. So, we will be getting this as 3 divided by 20. Why it is 3 divided by 20? Because it is where the moist soil is having a mass of 23, and also when it is dried it is getting 20. So, it is 3 divided by 20 into 100, which is nothing but 15. Now, once you get this value as 15, what is the next thing? The next one is going to be rho d. Rho d is equal to rho by 1 plus w. Gamma d is equal to gamma by 1 plus w. And gamma is equal to 1.8 into 9.81 divided by 944 into 10 to the power of minus 6. So, the answer that you will be getting will be how much? You will be getting it as 18.71 kilonewton per meter cube. Once you get it as 18.71 kilonewton per meter cube, please note it is not 18 because you should not in your case you are asked to find out what exactly is the value for gamma d for theoretical, not just like that. So what you have to use, gamma d is equal to g gamma w divided by 1 plus w into g. Okay, so because S is equal to 1 for theoretical curve, so what happens? We'll get it as 18.71 9 or otherwise 18.85. So your option will be option D. Yeah. So this is what exactly are the problems that I have kept. Now, do you want me to explain anything explicitly or something like that? Are all the problems clear, or you want me to explain any typical problem, any one? Are you all there?
Yes, ma'am.
Okay. Yeah, any typical part you want to explain
No,
or
ma'am.
no? Okay. So just I would like to once again have a quick recap through the part 1, okay? Because so the next class I will be concentrating more on the shear strength as well as the more of the part 2, which is nothing but the footing part. But always three-phase diagram always plays a major role, especially in this competitive examination. So please note, here I have given the classification of soils. I have given the classification for all types of soils. You can see that from here you have got two. What are the two that you got? You have got it for aeolian soils and residual soils. Explicitly they have not asked, but it is only the concept case. And it is also from the name itself, it's very clear. So please be very clear with all the types of composition and also about all these particle sizes. And once again, phase diagram, please be very clear with respect to the basic fundamental equations. What are the fundamental equations? Void ratio, porosity, degree of saturation, air content, as well as percentage of air voids. So void ratio E is nothing but VV divided by Vs, okay, and porosity is given by VV by V, okay. And because these expressions also you might be it might be useful for you whenever you are going to solve any of the numericals. And also some of the expressions I have not listed out here. As I told you here, please note there is also one more expression. What is that? You have to keep in mind n is equal to E by 1 plus E, because you have seen at least 2-3 problems you have used that equation. N is equal to E by 1 plus E. Then degree of saturation. Degree of saturation is given by VW by VV. So it is not only just the formula, you should also know in terms of the phase diagram. This expression also you have used in one of the formulas. Then air content, again VA by VV, and percentage of air voids is nothing but VA by V. Okay. So please note all these terms, all these expressions, it's not only in terms of the fundamental relationships, it's also very important. Now coming to the mass relationships, the mass relationships that you are having is MW divided by MS. Dry unit weight is equal to MS by V. Bulk unit weight is equal to W by V. Here, you have to be very, very careful with respect to the denominator, because the denominator for the dry unit weight as well as the bulk unit weight is same, that is V. It is not. So what is rho S? Okay. So here this is rho S, not rho sat. Okay. Rho S is gamma S is nothing but WS by BS. Okay. So this also you should not get confused. And saturated unit weight, once again I'm telling you, it is W sat by B. And what is submerged unit weight? So this also is very important, and this also you have used in one of the expressions. The river problem, you have used the same expression, gamma sat minus gamma W. So this is the reason why I have given all these problems, all these equations in the first class, so that no, so if you have studied it long time back, then it will be a very good recap for you. So then interrelationships, ES is equal to WG, very, very important. I think we have done around 3-4 problems based on that. Even bulk unit weight, G plus ES divided by 1 plus E into gamma W. Saturated unit weight, which is nothing but G plus E divided by 1 plus E, okay, into gamma W. And then dry unit weight, which is nothing but gamma by 1 plus W. And similarly, submerged unit weight, which is nothing but gamma sat minus gamma W. So it is equal to G minus 1 by 1 plus C. Please note, this is the expression from which we have got the expression for critical hydraulic gradient. Okay. And also the phase diagram is also very, very important. Now, soil classification, as I told you, I think we have not done much problems on soil sieve analysis. So these are some of the resources from which I have collected the questions, but there are many other resources also. So probably in the upcoming classes, I will be covering that. So sieve analysis, as I told you, we are having wet sieve analysis as well as dry sieve analysis. Okay, and hydrometer also, we have not come across much of the problems, probably as and when it is coming upon, because some of the topics will be very important, you may feel like, but it may not be so important from the this competitive examination point of view. So I request all of you to prepare an exclusive one notes itself for this subject, where all these things, all these formulas, as and when you keep on, because there are lots of formulas that are there, especially in the subject of geotech. So please keep on writing down all the equations so that no, you will not. And not only this, there are so many more also. Uh, I will be telling you as and when. So, but what happens is like all these expressions are very, very important. Like how I told you about the Hagen-Poiseuille's expression. Hagen-Poiseuille's expression, we know that it is a very tough to remember that. But it is very important to know the same, because if at all you want to know variable analysis, okay, how exactly it is going to vary for one parameter, it is important. Okay, so these are the two expressions. I will be again coming on to the problems on these things in the later stages. Okay, so MT is going to be the temperature correction, and also please remember there are three corrections. What are the three corrections that we have? Meniscus correction, temperature correction, as well as dispersing agent correction. We have three types of soils. This is a well-graded soil, the red one. Blue one is a case of gap graded, and the brown one is a poorly graded. And calibration graph. I'm not telling more about that hydrometer part. Once you get the problem, it will be good to remember that. And please remember this is very important. Uniformity coefficient is equal to. So this is a reason why I was emphasizing on all these expressions as I told you. So Cu is equal to D60 by D10. Cu, so it's not Cu, this is Cc. I think I didn't say it that time. Cc is equal to D30 squared by D60 into D10. And what is D60, D30 and all also I have told. And what do you mean by well-graded soil? So Cu will be less than 2 for a poorly graded soil, and it will be greater than 4 for a well-graded levels, and it will be greater than 6. And Cc should be between 1 and 3. And consistency index, I have told there are two methods. What are the two methods? It is going to be the Casagrande's method as well as a cone cutter method. For cone cutter method, it is going to be 20 blows, whereas for the Casagrande's method, it is going to be the 25 for the corresponding to 25 blows. Okay. Consistency. This also we have done today a problem based on the shrinkage limit. So what you have seen the case wherein it is semi-solid state, right? It's in a range I have told, right? This is the semi-solid state. So that is WP. Okay. And plasticity index also very, very important. You have seen today itself, you have seen one problem based upon liquidity index. So there are all chances wherein you can get a numerical based on consistency index also. So consistency index indicates how close is your soil to the plastic limit. Okay. So liquidity index indicates how close is the soil to the liquid limit. So consistency index, already you know the liquid limit. The natural water content you are verifying with respect to the plastic limit. And so that the value will become 1. And flow index is nothing but the slope of the flow curve. That is the previous slide. Yeah. The slope of this curve is called as a flow index. Activity also, today we have done 2 problems based on activity. So please don't ignore this topics as such, because there is nothing so difficult in this, but please ensure that you are aware of all these things. So activity is equal to IP by F, And sensitivity also we have not seen, but I am telling you, you are going to get the sensitivity based problems when you start with shear strength. Okay. Relative density Emax minus. Oh, today we didn't get a problem. This is also very, very important from the gate examination. Again, next class I will be telling. Then relative density in terms of dry density. IP cannot be negative. Okay. We have got a question wherein IP also was not IP, it was IL was negative, right? So we had a question based on that. So liquidity index plus consistency index is equal to 1. And so these are the different variations with respect to the relative density and activity and sensitivity. So I'm not highlighting more about this, but I just wanted to give you these numbers so that at any point of time, this should become like a good resource for you in your future also. So classification of soils, I have told you there are basically 9 groups of classification, 18 groups. So in this coarse grain soil is classified into 8 groups and the fine grain soil is classified into 9 groups. So gravels are classified into 4 and they are basically classified based upon the plastic limit as well as a plasticity index and also based upon the fines that are present. Okay, if fines is less than 5% and also if IP is going to be, if the fines is less than 5% and C is greater than 4, it is going to be well graded. Okay, otherwise it can be poorly graded. If those conditions are not satisfied, it will be poorly graded. If the fines are greater than 12%, IP will be less than 4, then we can have silty gravels. M represents silty gravels, C represents clayey gravels. The same table, when it is going to be, if it is greater than 6, the classifications will become SW, SP, SM, SC. That's all. This is a difference. Okay, the rest all remains the same. Coming to the fine grain classification, you have to remember this. So this is called as a plasticity chart. So this expression you should be very clear. And also the anything above the A line. So this line is called as A line. Anything that is above the A line, we call it as a clayey soil. Anything that is below that, we call it as a silty soil. And we have also told about the unified soil classification system, the main difference between unified soil classification system as well as the like IS soil classification system is we don't have the intermediate classification unified soil classification system. Clay structure, this also we had a question today, right? Wherein which type of structure is exhibited by a clay in a seawater. So this is a flocculator because the moment you add it into the salt water, it will be getting ionized. So the clay particles will get ionized and accordingly they get reoriented to form a flocculant structure. There are 3 minerals, kyolinite, montmorillonite and gibbsite. Yeah, this is a nutshell. So elite sheet will be having a total, elite and montmorillonite will have a total thickness of 10 angstrom and there will be potassium molecules in the case of elite, whereas it will be water molecules in the case of montmorillonite. And kyolinite is supposed to be the most stable. This also is very, very important. Might be you may not, because as I told you, like today I have taken some questions from some resource. So might be in the another one, this table itself is very important. The reactivity, aluminum is more reactive than calcium, then magnesium, then ammonium, then hydrogen, then sodium and lithium. This is based upon the activity series. So this is called as base exchange capacity. So whatever that is adhering to the clay will get replaced by another ions, that is this. This is called as base exchange and the cations that can be replaced by the other ion is called as exchangeable ions. What do you mean by isomorphous substitution? If aluminum get replaced by magnesium, then this is called as isomorphous substitution. And compaction also, I think this also we have got 2-3 questions based on the standard compaction test and modified compaction test. This table is also very important because today based on this also we had a couple of questions. So please make sure that you are very clear about it. So factors affecting compaction also I have told with respect to this also we had some few questions in this regard. So water content and how exactly with respect to energy it is changing, and also the different types of compaction methods. Field compaction method is basically done by means of a for clay we use sheepwood rollers, whereas for sand we use vibratory rollers. And this is also important. I think some questions I have seen, might it will be taken in the next session. So core of an earthen dam, the basic requirement for core of an earthen dam, it should be of less permeability, whereas a shell should have a higher permeability. And proctor needle is an instrument which can be used in order to get the in situ moisture density and all those things for the laboratory samples with respect to the field. And also for the this compaction curve is not exhibited by the sandy soils and all. So as you can see here, and permeability, very important. So I think this also we have seen. Pore pressure and all those parameters we have seen. HW is equal to U by gamma W. We have done, based on this itself, we have done one or two numericals today, and elevation head also. And this also, Darcy's law also, we had some questions based on Darcy's law. Seepage velocity is equal to V by N. Today's class we didn't see, but this generally keeps coming in the examination. Vs is equal to V by N. Validity of Darcy's law. So whenever a water flows in it, we say that this is a Reynolds number, V into dA by rho into rho W divided by eta into G. So that should be less than or equal to 1. Then K is equal to C into D10 square, where C is nothing but, what is that C? I have told you the Haken-Poiseuille equation also. If you remember, I had told you the expression that C is what exactly is coming here. So K is proportional to D10 square, but generally they suggest a value for C is equal to 100. If that is the case, we can put K is equal to 100 into D10 square. This also I have told in the last class. And we have done the problem also based on that. Yeah, this also we have done. And constant head flow, K is equal to Q into L divided by H into A into T, and falling head, this expression. Field test for unconfined aquifer. So if the case of an unconfined aquifer is a case wherein we will be having the yield. What do you mean by confined and unconfined? Confined means the aquifer is going to be involved with, it will be embedded between two impervious stratum. So that is called as a confined aquifer. Whereas for an unconfined aquifer, there is only one impervious stratum in the bottom, top it is pervious. So there we'll be having H2 square minus H1 square will be the height difference. Whereas in this case, it will be H2 minus H1. Stratified deposit, today's class, as I told you, again, we didn't come across a problem, but generally this also comes. Vertical flow, horizontal flow. Vertical flow, it is given by H divided by H1 by K1 plus H2 by K2 plus H3 by K3 and so on. Whereas for horizontal flow, it is K1 H1 plus K2 H2 plus K3 H3 and on. Stresses in soils, sigma V is equal to gamma into Z. Pore water pressure is equal to gamma W into H. Effective stress is equal to sigma dash is equal to sigma minus U. And also for a downward flow, the effective vertical stress increases by gamma W into H. For upward flow, it decreases by an amount equal to gamma W into H. Why where the upward flow it is decreasing? This is what this also similar type of question was there today. So in this case, we have considered in the question that we have considered, here was a point where we required, but this is generally for a soil wherein the upward flow is existent. So in that case, this will be the height difference for which the flow happens. Now, what is a quicksand condition? It is a condition wherein the base soil will be losing its strength, and base soil will not be able to support our load. So sigma dash will be equal to 0, and critical hydraulic gradient is given by G minus 1 by 1 plus C. And seepage in soil, so Laplace equation dou squared H by. So this and all also two questions we had for the session today itself. Equipotential lines are the lines connecting equal heads. Flow lines are the lines connecting the direction of seepage. Space between the two flow lines as per flow channel. Okay. The flow in the channel is given by K into H into K into B into delta H by L. And also total flow is equal to Q is equal to K into H into NF by ND. Against piping failure, the expression is given by delta H divided by L minimum. Now, for an anisotropic soil, this is also very important. We have done two numericals based on this, one theory and one numerical. So, whenever we are going to have an anisotropic condition, we have to do a transformation on the x scale or the z scale. X3 is equal to x2 into square root of kz by kx. And similarly, x3 is equal to z divided into square root of kx by kz. Consolidation. What are we trying to do? For this also we had a question today. Consolidation checks the primary consolidation. Delta H by H is equal to delta E by 1 pi E naught. Okay, AV is equal to minus delta E by delta C. Coefficient of volume change AV by 1 plus E0. Okay, so this is also very important. Compression index. See, why I'm showing all these things is like, now you have already seen all the solutions. So please, you should be able to correlate those things with respect to the first class. So I know first class I have, because I have covered the entire thing, might be, unless otherwise you don't go through that, you will not be able to solve the problem. So that's the reason why I'm just once again, no, after doing this, you should know where all you should be emphasizing whenever you are revising these more parts. So coefficient of consolidation, CV is equal to K divided by MV into gamma W. Time factor is equal to CV into T divided by H square. Degree of consolidation for U less than or equal to 60%. What is the expression? And for U greater than or equal greater than 60%. And then coming to the shear strength, for main shear test, also we'll be able to shear the sample within a cylinder, and the untrained shear strength is given by T divided by pi d square into H by 2 plus D by 6, and shear strength is given by tau is equal to C plus sigma tan phi. Failure angle is equal to alpha plus, sorry, for alpha is equal to 45 plus 5 by 2, and this is a principal stress equation. Yeah. So this is what we had, and I hope all of you are clear with all the things. And do you want anything else to be explained or anything like that? Yes. If you don't have any queries, I will just end the session.